Good day, ladies and gentlemen. This is Banners Online Maths. Today, let's see the problem we have on the board. Okay. The question says, given f of x equals to x plus 1 and then g of x equals to x minus 2, we are asked to show that the composition of the two functions are commutative. Okay, solution. Given the first function f of x to be equals to x plus 1 on the board, and the second function g of x to be equals to x minus 2. We are asked to show that these two functions, f of x and g of x, are commutative. What do we understand by commutative? In terms of commutative, we're asked to show that, let's say for instance, a dot b is equals to b dot a. That a times b is the same thing as b times a. Let's say for instance, if we are given 2 times 3 is the same thing as 3 times 2, because 2 times 3 is said to be what? 6. And again, 3 times 2 is also the same thing as what? 6. So the first function here is f, and the second function here is g. So we wish to show that f dot g is equal to g dot what? F. That's exactly what they say we should do. Okay, let's do that. Of course, this is one of the composite question. It's a composite function, f of x and that of what? G of x. Okay, so in this case, we're asked to show that f of x dot g of x is equals to g of x dot f of x. And you must know that f, since a composite function, f of x dot g of x is the same thing as f of g of x, and again g of f of x dot f of x is the same thing as g of f of x. Remember, they are said to be composite function. So we need to show that the left hand side is equals to the right hand side. Okay, let's do that. Now let's solve for the left hand side, which is f of g of x. For f of g of x, now you ask yourself, what begins this? Is it f or g? Of course it's g. It's f, sorry. So out of these two functions, f of x and g of x, which one contains f? So it's the first one. You bring it out. We record that f of x was given to be x plus 1. X plus 1. Therefore, we're looking for f of g of x. Therefore, our f of g of x will be equals to, now let's compare something. Before we meet this bracket, what do we have here? F, right? Before we meet this big bracket, what do we have here? F, which simply means that they are said to be same function. Since they are same function, we can now compare whatever they have inside the bracket. And what do we have inside this bracket? X. And what do we have inside this big bracket? G of x. What does that mean? It simply means that x is now equals to g of x, which simply means that here, wherever you see x, you replace it to be what? G of x. Let's do that. So instead of x, we now have g of x, then followed by plus what? 1. As a matter of fact, we now have this to be, do we know g of x? Yes, g of x was given to be x minus 2. So instead of g of x, we now have x minus 2, then followed by plus 1, followed by plus 1. Let's simplify. If we simplify this further, we are going to have this to be that x minus 2 plus 1 automatically will give us minus 1. So this is the solution of the left hand side. Remember, we are trying to show that here that the left hand side, which is f of g of x, must be equal to the right hand side, g of f of x. So we have found the solution of this left hand side, f of g of x, to be x minus 1. Next is to find the solution of the right hand side. So if the solution of this left hand side gives us the same solution of the right hand side, we now conclude that the function f of x and g of x are commutative. Okay, for